Alright, so what we'll be doing today is finding the inverse of a 2 by 2. Y'all did that in Algebra 2 trig, plus you can do it in your calculator. I'll show you how to do that, so that won't be bad. Then we'll use matrices to solve matrix equations, and then we'll decode and encode messages using matrices. Alright, first question is, what happens if we multiply these two matrices? So let's go ahead and do that together. First of all, can we multiply these? Yes, because both of them are 2 by 2. But do they have to be the same when we multiply them? Very good. So our size of our matrix is going to be a what? Good. Let's go ahead and make it. Alright, tell me what to put in this first spot. 1 times?
1 times 1.
Plus?
3 times 0.
Very good. Next one?
1.
Plus?
0.
Very good. Next one?
3 times 1.
Nope. 4 times 1.
Oh, 4 times 1.
Plus?
6 times 0.
And then last one?
4 times 0.
Plus?
6 times 1.
Good. This just...
Is it row 1 and column 1, or is it?
Yeah, first spot, and this one is row 1, column 1. Then it's row 1, column 2.
Okay.
And so forth. And now let's simplify. So Kelsey, what's my first spot going to be?
1.
Katie?
3.
Very good. Kaya?
4.
And Ransom?
6.
Good. Alright, so we multiplied these matrices, and look at the matrix we got. What do you notice about it?
They're all visible, but
Same as what now, Darian? Same as the first matrices we used. Okay? So what happens when we multiply a matrix by, what's this matrix called? Do y'all remember? Identity matrix. You get the same one. And if you didn't remember, all of these are identity matrices because they have zeros everywhere and ones in the diagonal. That's how you know it's identity matrix. So what I'm trying to get at is if the product of two matrices is the identity matrix, like if you multiply two matrices and get one of these matrices, they are inverses of one another. Actually, multiplicative inverses of one another. So I'm going to zoom out some. Again, if you multiply two matrices together, they give you the identity matrix. That means they're inverses. So that's what we're going to check here with these matrices. We're going to find A times B and B times A. And if they both equal this matrix, the identity matrix, then they are inverses of one another. So before we get started, if I were to multiply A times B and I got like a 3 here, would I have to do anything else? No, because it's not 1. It has to be these exact numbers. So if you get one that, what now? So if you get one that's not one of these numbers from the identity matrix, you can stop. Let's go ahead and start with A times B. We know it's going to be a 2 by 2, just like the one we did up top. Darian, what's going to be first here?
2, 1.
Plus?
1.
Good. Please turn your phone on silent. Abigail, next one. This spot, multiplying A times B.
2. I'm using negative. And plus 1.
Times what now? Very good. Alright. Brandon, what's the next one going to be?
It's going to be 1 times 1 plus 1 times negative 1.
Very good. Darian, last one.
1. -1.
Plus. Good. Alright, so Katie, in this first spot, I'll have what?
1.
Good. Miles, what about this spot?
-0.
Very good. You said I need to slow down? Okay. That's fine. Y'all just tell me if I'm going too fast and I'll slow down. Good. All right, Alyssa, next one. Good. Colby, last one.
1.
Very good. So,
Miss Horton,
yes,
you have Antonio Brown.
I do.
I need to see him in student services.
Okay.
She got so excited.
See ya. So we found that one's the identity matrix. Now we have to check B times A. And what I'm going to do, and you don't have to if you don't need to, but I'm going to swap the order of these. That way it's easy for you to see how to multiply it. So I'm going to write an A on this side of B. So nobody gets confused because we're doing B times A now. Same thing, a 2 by 2. So when we multiply these two matrices, Jalen, what's going to go in the first one?
Wait, which one? Which matrices?
These two.
1 and 2.
Plus.
2. Negative 1 times 1.
Good.
Okay.
All right, Kate, what's going to go in the next one?
Goodness. Negative. I'm just not paying attention to this. If you multiply A times B, would it not be the same answer as B times A?
That's what we're seeing now. It's not always the same.
Okay. Okay.
Oh, my pen just broke.
Would it be negative 1? No, 1 times 1 plus negative 1 times 1.
Good. Who am I? Oh, Logan, what's going to be in the next one?
B times A?
Yes.
Okay.
You can put it on my desk. Thank you.
1 second. Okay, 0?
Yes. So it'd be negative 1 times 2. I'm just going to write it out. I know you did it in your head.
Negative 1
Plus 2 times 1.
2 times 1.
Good. All right, and then Kaya, my last spot. Good. All right, now we'll just evaluate. Logan already said this one was 0, and that's correct. Everybody, what's the first one going to be? And good. And like I said, these will not be the same. I know for numbers it is, but for matrices it's different. Like when you swap the order, it's going to change it. But this one it doesn't, but some of them it does. So these, we would say, are inverses of one another. These are inverses. Because we multiplied them both, swapped the order, and they're both the identity matrix. Alright, do B on your own. Multiply A times B, then B times A. And if one of them doesn't give you the identity matrix, you can stop there. And if you're using your calculator, that is fine. You don't have to write it out if you don't need to. Yeah. You good? Okay, I'll take it.
It's not that kind of song.
multiplicative inverses.
If I multiply these two by
Okay, just write about this file.
Alright.
Alright, so for A, B, what did y'all get for the first one when you multiplied it together? Just this first number. 3 or negative 3? Okay. And from there, you could just stop. Once you got that first number and it is not a 1, like the identity matrix, you can put no. These are not multiplicative inverses. But let me just show how we got the negative 3. It'd be negative 2 times 1 plus negative 1 times 1. That'd make negative 2 plus negative 1. Does everybody see that?
So it would have to be 1 plus 2.
Yes. If this is not a 1, you don't keep going. Try C and D on your own as well, these two. And like I said, if you get to one number and it's not that 1, you don't have to do the rest of it. You just put no, they are not inverses. Then they are inverses. But if it's something else, like in this one we got a negative 3 first, so it's not the identity matrix, it'll be no. Does that make sense? This one will be what right here. So is it yes or no? Very good. Can you stop there? And the next one. Everybody done with those two? What did you get for the first number here? Very good. Everybody got 8? I don't need to go over it. Very good. So the answer is no. What about for this one?
Negative 6, I got 4.
Did everybody else get that? Very good. So the answer is no. So these will be really easy to do on your test. You just have to make sure they're both the identity matrix. Alright, flip it over. So that was checking if they're inverse matrices, or if two matrices are inverses of one another. This one is actually finding the inverse. And here's the formula right here that we're going to use. But to do that, we have to label these as A, B, C, and D. These are pretty easy, and you can also do these in your calculator. Do y'all remember what a determinant is of a matrix? No? Okay. Determinant is when you cross multiply here and subtract their products. Do y'all remember doing that? No? Okay. We'll write down this formula. Determinant, DET, is A times D minus B times C. That's the formula. So in this case, our A is what? 3. So it'll be 3 times minus times, yes. That's how you find the determinant. So basically like cross multiplying here, subtracting, cross multiplying here. So your determinant will be 3 minus what? Which is 1. Good. Alright, so what we just found in this formula is this part, this AD minus BC. So now we'll set up this formula. It's just going to be 1 over our determinant, which is what here? 1. And now the matrix, see the difference between these letters and our letters? You're just flipping the A and D, changing those spots. So right here we'll have what? And here? 3. You just swap these two. And then B and C, they left the same, they just changed the signs. So this one's supposed to be what? 2 and 1. And all you do from here is multiply these, which in our case is super easy because our determinant is just what? 1. So the inverse of this matrix is 1, 2, 1, 3. And you can write this as A to the negative 1. That means A inverse of this matrix. How would I check if these were inverses of one another?
Multiply it by the matrix.
Yep, and then if it is, it will give you what when you multiply them?
1, 0, 0.
Identity matrix. Good. So you check it just like the problems we just did, which I'm not going to make you do. But on the test, I suggest doing it. Alright, 2 more together. First up is to find the what? What's that called? Determinant. Good. Tell me how to set that up. 5 minus, which would be, go ahead. Yes. Gosh, I didn't mean to make all these 1. None of the rest of them are 1. Very good. Okay, so this is going to be 1 over 1 times, what do we do with the 5 and the 3? And what do we do with the 7 and the 2? Yes, but leave them the same place, right? So 1 times all of this will be just 3, negative 7, negative 2, and 5. That's the inverse. Questions so far? Alright, 1 more together. Let's do E together. Alright, first up, find the determinant. So, Miles, tell me how to set that up. So, say the numbers. E. Say the numbers instead of the letters.
-1, 4 minus 4 and 1.
Good. So, Abigail, this will be what right here? Minus. Just minus 4, right? Which is what? Good. So that's our determinant. So we set it up as 1 over our determinant, 1 over that number. Tell me my new matrix, Brandon.
It's going to be 4, 1.
This spot right here. Good. This one? Good. The numbers, they're the same as our matrix. Miles, we're just swapping negative 1 and 4. Swapping these two. And then these, we're just changing the signs. So most of the time when you do an inverse of a matrix, most of the time they'll be fractions. The first 2 we did were just super easy because the determinant was 1. But most of the time you'll have fractions like this. When we divide 4 by negative 8, we'll get what? Negative 1/2. Good. Next one. 1/2. Next. Close. 1/8 and 1/8. Good. That's it.
Did you swap the numbers?
Yes, you swap these two and then make these negative or positive or whatever the sign is.
Oh, so you swap and change the sign.
Yes. Do C and D on your own. Then we'll go over. Alright, let's go over it. So tell me how to set up the inverse, Kelsey.
You probably just read it.
So it'd be,
-3 times 2.
which is -6 minus,
6. -6, so yeah.
good. So when we have a determinant of 0, we know that when we set up for the inverse, it's going to be 1 over 0 times whatever. And 1 over 0 is what? Undefined. So this one has no inverse. So anytime you have a determinant of 0, it's no inverse. On this one, Amber, tell me how to set up for the determinant first.
You multiply the 2 and -2. And you multiply the -6 by 1.
So you would get -2 minus,
-4 minus 6.
oh sorry, yes. -6, which would make what?
Or plus 6.
Plus what now?
2.
Okay. So tell me how to set up for the determinant, Colby.
1 over 2,
Very good. Times.
-2, 1 over 6, -1 and 2.
Very good. So when we multiply them, Katie will get what?
-1, 3, -1, and 1.
Perfect. Y'all have any questions about finding the inverse? Cool. Alright, last thing we're going to do today is based on what you're going to do tomorrow on your own. So make sure these last few that we do that you know how to do them. So tomorrow we won't be confused, okay? Go ahead and put, I forgot to put bars around this. This is a matrix. We are going to use matrices and inverses to encode a message and decode a message. So encode is when you actually have a word that you can understand, and we're going to change it to numbers where somebody wouldn't understand, when somebody wouldn't know the message. And then decode is when you have all this gibberish right here and you're trying to figure out what word does it spell. Alright, first thing we'll need to do, and this is going to be tedious, but it'll only take a second. We're going to have to list the alphabet. G. You know the alphabet, so I'm not going to go slower. Because each letter is going to have a number assigned to it. If y'all go into anything in mathematics in college, you'll do a lot of decoding and encoding messages. They're pretty fun. I think they are. So A is going to be 1, B is going to be 2, and so forth. Trust me, you'll need to write this down, especially for tomorrow when you will not have me up here telling you what letter is what. I'll give you a minute to do that. Alright, the directions for encoding and decoding are different. Obviously you can't do them the same way because one's letters and one's numbers. But the first thing you're going to do is turn math, the word math, into numbers. And how are we going to do that? Using this, what we just drew out right here. So the letter M is the number what?
13.
Okay, and then A is, T is 20. H is 8. And that comes from right here. That's just the number of that letter in the alphabet. Alright, so to encode a message, what we're going to do is turn this into a matrices. First number is going to be 13. And then you're going to go down from here. 1. And then 20 and 8. And the coding matrix is the same for all 4 of these. And it's going to be the same for the example you're about to do on your own. But to encode it, you're just going to multiply this word by the coding matrix. -2, -3, 3, 4. And y'all know how to multiply matrices, so I'll go ahead and let you do that on your own. Go ahead and multiply those 2 matrices together. Let me know if you need help. Alright, tell me the first number y'all got in the first spot. What'd you get? Somebody said it. I got -29. Did y'all get that? No? Uh-oh. Let me see. 13 times -2, that's going to be -26 plus 60. Yeah, that's right. Let me see. I think I might have set up the matrices wrong. Give me a second. Yep. I'm sorry, guys. This is correct. They just need to be swapped order. The coding matrix needs to go first. That's my fault. So let's rewrite that first. -2, -3, 3, 4, 13, 20, 1, 8. I'm sorry. So yes, Kate, it does matter what order the matrices are in when you multiply. Swap the order. Yeah, got that other order here. I accidentally wrote this one first. The coding matrix is supposed to go first.
Okay.
So that's going to change your product when you swap them. Yes, order matters when you swap matrices. Yeah, that one's good. Yeah, when you multiply, it's got to be this one first, coding matrix, then this one, which is what you did here.
Okay, so it's
Yeah, that was it. Anybody need more time? Okay. I don't know if y'all are interested, but me and Miss Walker were just talking about this. Back in the day when they had like wars and stuff, a long, long time ago, they used to use this kind of stuff, this math, to encode messages to one another so their enemy wouldn't know what it was. I just thought that was pretty cool. Alright, where'd y'all get in this first spot this time? Yes, that's better. This one? Good. Next one? And perfect. Much better. So what you would write to your ally as a coded message, not this matrix, but a list of numbers. And the list would be negative 29, and then go down 43, negative 64, and 92. You would just give them this list of numbers plus the coding matrix, and they could undo it and know that you were saying math. And I'll show you how you can undo it, decode. So as you've noticed probably that these are the same numbers, because it's the same message. I'm just going to show you, if you were given this, how to decode it. And it's very similar. The only thing is, instead of multiplying this by these numbers, we have to multiply this by the inverse of this matrix. So to decode, you just find the inverse and multiply it. Okay, so I'm going to write the coding matrix down here so I don't have to keep going back up. And we're finding the inverse of it. To find the inverse, we start by finding what? What's it called? Good. So the determinant would be, which is negative 8 minus. Good. So when we do keep, change, our determinant is what? That's going to help us out a lot. We'll have an easy inverse. So it'll be 1 over 1 times, what do we have to swap? A and D, so 4 and negative 2. Do we swap these? Nope, just change the signs. So this, when we multiply it by 1, will be our inverse matrix. So to decode this message, all you do is multiply this, make sure you put that first, our inverse matrix, times this matrix. Remember that when you're creating these matrices, it's got to be negative 29. Where does the 43 go? Below or to the right? Below. And then negative 64 and 92. Go ahead and multiply those. Yep, multiply.
Miss Horton?
Yes.
Did Love and Modern make it in?
Yes, who's just starting?
Party, thank you.
Unless they're the same size, you cannot subtract them. You can put it on my desk. Thank you.
Miss Horton?
Yes.
Is Mackenzie McGuire there?
Yes, ma'am.
She's just marked absent.
Okay.
I'll take it off.
Okay.
Thank you.
Okay. What'd y'all get here?
This is max.
13, 20. Good. So you would write it out as 13, 128. And those letters are what? Math. Pretty cool. So what your assignment will be tomorrow, and we're going to go over one before you get started, but I will give you stuff like this, and you'll have to decode it. It'll be a secret message from me. All right. Y'all have a good day.